In this section, we're going to be choosing a factoring method. So let's look at a first example. You want to tell whether each expression is completely factored or not. So we have 2x parentheses x squared plus 4. So if we look at it and you look at what's inside the parentheses, they don't have any common terms other than 1, and pulling out a 1 would make no difference. So this term is completely factored. Now we're going to look at factoring negative 2x y squared plus 16y minus 32x. So let's start off by just looking at the problem, seeing if there's any common terms between all the elements in the equation. We can see that they all have an x, so let's go ahead and pull out one x. Now we can also see that they all have at least a factor of 2. That would be the greatest common factor. So we're going to go ahead and pull out a negative 2. So if we pulled out a negative 2x from the first term, we would be left with a positive y squared. It's positive because you're basically dividing negative 2 by negative 2. Now the 16 would become negative because you're dividing 16 by negative 2, so you get negative 8, and you pulled out 1x, so you're left with negative 8y. Now negative 32x, divide that by 2, you'd be left with a positive 16, and take away the x. So as you can see, you can leave the negative 2x on the outside. Now if we look at what we have in the parentheses again, we can see that we actually have a perfect square trinomial. And because we have a perfect square trinomial, let's look at the factors of the y squared and 16. So the y squared would be y times y, and then the 16 would be 4 times 4. So we have a perfect square trinomial, so we can see that 4 times y times 2, which is basically the 2ab in the middle, would give us the negative 8y. And because it's a negative 8, we know that it's going to be y minus 4 times y minus 4. So we can just write y minus 4 squared. And now that we've done that, we've fully factored it. Now we're going to look at factoring in a different way. We have the problem 3n to the fourth minus 15n to the third plus 12n squared. When we look at this, we can see that we have some common factors. The n's, first of all. We can see that all the terms have at least 2 n's. So we can pull out an n squared. And we can see that the greatest common factor of all three terms is a 3. So if we divide all the terms by 3n squared, we would be left with n squared minus 5n plus 4. And we can go ahead and check and see if this is a perfect trinomial, which in this case it is not, because even though the first and last term are perfect squares, when you multiply one element of the last term times one element of the first term, so 2 times n, and then multiply it by 2, you end up with 4n, and that does not equal 5. So we're going to go ahead and have to factor it out the other way. So we want to look at the factors of 4 that add up to negative 5. So we're going to look at negative 4 and negative 1. Because if we multiply negative 4 times negative 1, we end up with a positive 4. And if we add them together, we get negative 5. So we know those are the factors. So we can go ahead and make parentheses n. We're going to put n at the front because we see that we just have an n squared with no numbers in front. And make another set of parentheses. Put the n in the front there. And we can put our factors in, negative 4 and negative 1. And that would be our factorization.